Okay, so the purpose of this video then is we're going to turn on the scintillation equipment here for the first time and start looking for our first gamma ray scintillation signal. Okay, so what I've done to start then is at the very top of the detector up here is I did put a cesium-137 source. You can't see it in the camera, but if I take the audio detector here and I hold it up here, you can hear all the ticking going in there, so I do have a gamma ray source up there. So the gamma ray sources are going everywhere, and some of them, of course, will be going down through aluminum housing in the sodium iodide crystal. And, of course, what's going to happen then is the signal that we get will be piped out of this cable here and sent into the amplifier as I showed you. So let me back up a bit more here, and let's maybe zoom into this region right here, because as a student, this is what you'd be focusing on in a minute here. We'll get to the laptop maybe in the next video, but for now, let's just get that first signal to come in, okay? So the first thing we do is when you turn on the high voltage power supply, it has its own power here, own power switch. It plugs directly into the wall. There's a cable coming out of the back of it. It's plugged in. And for this detector here, it requires about 600 volts of high voltage to get going there. So I turn the first knob to 500, the lower one to 100, and we're good. It's a fairly new detector, so 600 volts does just fine. Some of the older ones that we had sort of were replaced here could require even as far as 2,000 volts, 1,200 volts to operate properly. This one's fine at 600. Okay, so that's on. And of course, the detector is now being biased with that high voltage. So in this cable here, this thick one right here is where the high voltage is going in. And so everything's on now. Okay, so but I don't see anything on the oscilloscope. Nothing's happening. I have the amplifier here, and so nothing's happening. Of course, students usually, not usually, but can sit here for a little bit not realizing that they haven't turned the NIM crate on. So let's turn on the NIM crate, okay? And as soon as I do that, you can see that a signal pops up, okay? So already we're seeing some signal, and just as a quick test here, let me just back up here. We always like to do sanity checks on these things here, so I'll just pull this back. And let me just pull the cesium source away from the detector for a minute. And you see that the signal has changed here. It sort of became a little more spurious, sort of all over the place. And let me put the source back on the detector. 3, 2, 1, it's back. Okay, and so you see the signal then kind of fills in a bit more when the source is on and off the detector. So we see then, so I'll just do that one more time. It's on right now. Now the source is off the detector, away from the detector. Now it's back on again. Okay, so it's just a little bit of a check there to see that indeed it seems like the signal we're getting here is coming from not only the detector, but also sort of happens when there's a source, a gamma ray source on the detector. Okay, so there you go. All right, so a couple things now. What do I do now? Well, you can see that see that most of the time the signal is sort of confined to this envelope right here. And that's pretty cool. And there's some spurious ones that sort of consume the whole oscilloscope display, and I'm not really prepared to say what those are. They're either noise, or maybe some, no kidding, some high-energy cosmic particle from outer space striking the detector, some background radiation, could be any or all of the above. But for the most part, it seems like all the so-called events I'm getting are sort of within this envelope here, so I'm kind of happy with that. But it's kind of small. I don't really see anything. It's sort of flat there. I'm not using the whole oscilloscope display. So a couple things I can do. I can turn up the gain on the oscilloscope like this to bring out more of the structure, which I will talk about. But this may not be the best thing to do, and let me tell you why. Is because the data acquisition box here that we're going to be using in the back here, little black box that I talked about in a past video here, actually can accept a signal between 0 and 10 volts. So if it can accept a signal between 0 and 10 volts, we sort of like to give it a signal between 0 and 10 volts to use all of its so-called dynamic range. This signal here, we're at 500 millivolts for division, is almost like 1 volt, 2 volts, 3 volts. This is like a 3-volt signal. So basically between 3 and 10 volts is never being used for anything, so we're underutilizing our equipment. So let's not do that. So let me turn the gain back down to where it was. And instead what I'll do now, let me turn the amplifier up. That's what the amplifier is for, right? So a couple things I can do. Here's the fine gain knob, and I'll start turning that, and you can see that the signal grows. See, that's what an amplifier does. Let me turn it back down. I'm not making a lot of progress here. I mean, 10 volts is going to be like 1, 2, 3, 4, 5, maybe clear up here, almost filling the oscilloscope. So I'm not going to do it with a fine gain. Let me turn in the coarse gain right here from 20 up to 50. So now the signal's getting kind of nice and large now. All right, something like that. And I can go up even more if I want, go up to 100 if I want. But the problem with doing this, getting up to 100, is that, and maybe I can turn the fine gain up, is you can see that I'm getting very close to this flat top here on the signal, which is saturation of the amplifier. That's sort of a point there where I've reached 10 volts, and the amplifier just can't boost anymore, so it sort of bunches everything up into this flat top here. The signals just don't get any larger. So I want to stay away from that, because remember, I am trying to do some energy discrimination here. So I can turn the fine gain all the way down. I'm still a little too close for my taste. So what I'm going to do is I'm just going to turn the coarse gain back down to 50, and maybe I'll turn the fine gain up a little bit to there, and I'll just sort of leave it there. I'm sort of comfortable with this. I'm sort of not that close to saturation. Some of those spurious signals are getting saturated, but it looks like most of the events I'm seeing in here are indeed within that envelope there, nice and round and a consistent shape in there. Okay, so a couple of things I'd like to tell you now about what's happening is, remember that this voltage that we're seeing here is basically coming from this input cable right here, which is coming right out of the preamp. So in other words, this cable right here it contains voltage pulses that are coming more or less directly from the detector. Okay, they go through the preamp, but they come from the detector, which has, in scintillation, the signal is proportional to the energy of the gamma ray. So the voltage is proportional to the energy of the gamma rays coming in, and we're amplifying it here. So that means that the signals that we're seeing here are proportional to the gamma ray energy. And that's kind of cool. So indeed, this signal that we see on the oscilloscope is showing us all of the gamma ray energies that the detector is seeing. Okay, now we need to be a little more careful about that. And the way I'll do that is I'll play around with the oscilloscope trigger just a little bit. See this horizontal line here is the oscilloscope trigger. And if I sort of start moving it up, you can see that I really start losing some of those events in there. By triggering just on the peak, I've sort of lost all that infill in there. But let me just tell you about what you're seeing here. It sort of helps me describe what the signal is here. Okay, so what we're seeing here then, by setting the trigger level so high, we're only causing the oscilloscope to sweep when the voltage coming out of the amplifier sort of reaches this level, way up here where that horizontal trigger line is right here, way up there, and that's about it. Okay, and so what I'm doing here is I'm causing the oscilloscope to trigger only on the highest energy gamma rays that are coming in through the detector. And for cesium-137, which is what this little disc is right here, these highest energy gamma rays are about 663 kilo-electron volts. So I'm pretty sure that this envelope here represents the gamma energies of 663 keV. Okay, that's sort of what I'm doing here. Okay, so we'll pick this up in the next video.